Welcome to Freedom from Fossil Fuels. This is the lightning round of the introduction deck for F4. I'm making it because the full version is about an hour and a half long, and I wanted to make a copy that would quickly run through the summary for those who would like to see a quick run, an introduction to all of the slides. So the full version and far more information, including follow-up briefings, is at f4blog.org. With that, let's jump right in. These slides cover how climate change works, what it puts at risk, and how we're going to fix it. There's some caveats here, but the core of it is this aims to be politically neutral. It aims to be a foundation for further research. It's not a full answer in itself. This section goes through how climate change works, showing how human fossil fuel use has heated our climate at a pace unprecedented in Earth's history. This is a summary of the greenhouse effect, showing how visible sunlight passes straight through the atmosphere. It does not have interference from any gases. When it hits the surface, some of it is converted into infrared light, which is then captured on its way out by greenhouse gases. So the more greenhouse gas you have, the more solar energy is being transferred to Earth's atmosphere. And this shows how changing greenhouse gas amounts have changed Earth's climate over its history. We have everything from snowball Earth, 25 degrees Celsius colder than the pre-industrial era, to Eocene Earth, 7 degrees warmer, and the changes at that level of heating were enough to turn Antarctica and Australia into forested continents, to give you a sense of how huge an impact these changes in temperature can have. This looks at the natural carbon cycle. Carbon does very naturally in Earth's climate. Volcanoes emit carbon from the interior into the atmosphere, and then a process called weathering takes carbon dioxide from the atmosphere, moves it through the ocean to the seafloor to return the balance from volcanoes. Normally, that cycle works in rough balance. We have completely tilted that balance over and shattered it with fossil fuels, which emit about 100 times that natural rate per year. About 5 gigatons of that 10 gigatons per year is going straight to the atmosphere. About 5 is being absorbed in overtime work by soil plants in the ocean, which is having severe impacts on the ocean, particularly making it more acidic and harder for marine life to live in. Over this, the human era, the industrial era, we've gone from about 600 gigatons of carbon in the atmosphere to about 870. This is a look at what how that plays out on a geological timescale. Effectively, the amount of warming of emissions we've done looks like a vertical line against the changes in nature. There is no natural comparison to what we've done. If you look at the most severe heating impact that we know of happening in nature, it was about 55 million years ago, and we are currently warming the Earth several times that fast. So again, what we're doing is unprecedented as far as we can tell in Earth's history, and certainly in human history. So the last ice age to the pre-industrial era involved a rise of about 95 parts per million of carbon dioxide over 20,000 years. And then we have been relentlessly raising it from there to the point where the carbon dioxide level in the atmosphere today is further from the level in the pre-industrial era than that era was from the last ice age, just to give a sense for how huge this impact has been. And this has led to a clear upward trend in temperatures. We haven't done all of the damage yet because the full impacts will take decades to centuries to play out, but there's no debate over where we're headed. Earth's 6 warmest years in recorded history at the time that I wrote these slides were the previous 6 years. At the time I'm recording this, a little bit later, 2021 has now joined that group. And these slides, again, were made a little bit earlier. So this was as of the 2015 Paris commitments. COP26 has updated them a bit, but the core problem still stands. Countries have signed on to a warming target that their individual plans are not able to meet. And even those insufficient national plans are not being met because countries are dragging their feet on actually delivering. So we're looking at these top 2 ranges in this red and orange range. While we would need to see very steep and consistent emissions cuts to get to 1.5 degrees Celsius or even 2 degrees Celsius warming track by 2100. With that, let's jump into what this all puts at risk and how fossil fuels unleash severe pollution and climate damage, making Earth overall a more hostile home for human life. I'm going to jump pretty quickly through this extreme weather segment because there is a lot of detail here, both on these slides and in the citations if you'd like to read more. But the core of it is that climate change basically makes life on Earth more difficult than it was before. We can look at California as an example of how this plays out. I compare weather to a speedometer, where it swings back and forth, and even in an age of climate change, any given year, it can still be normal. The problem is that the extreme zones are getting wider and wider, and when you get into those extreme zones, they're getting more and more severe. And the 2010s in California are a terrifying case study in how this plays out. Just consistent shattering of records for wildfire severity over the decade, and only getting worse from here. This slide covers how we know that these trends are driven by climate change, because extreme weather has happened naturally throughout human history, but climate change is now getting so severe and science is improving enough that we can now conclusively show that events happening today would not have been possible before human-driven climate change. This slide goes through some of the major climate change accelerated natural disasters of the last couple of decades, and shows that these disasters are able to shake even the wealthiest countries on Earth. And for countries that are already teetering on the brink of instability, climate change driven disasters can throw them completely over the edge, causing humanitarian crises and global aftershocks. And then finally, here are feedback loops where climate change accelerates itself by driving natural threats that further raise the speed of the warming Earth. So the first one is permafrost. This is frozen soil across the entire northern hemisphere of the planet. It contains huge amounts of methane and carbon dioxide, both greenhouse gases. As the planet gets warmer, permafrost melts, emitting that greenhouse gas, thus further accelerating warming and making permafrost melt even faster in a vicious cycle. The same happens to ice in the North Pole, because ice and snow reflect sunlight, whereas when they melt and become dark seawater, seawater is dark because it absorbs a lot of light, a lot of heat. So the more ice melts, the warmer the Arctic gets, and the more the Earth heats and the faster the ice melts. Both of these are vicious cycles that make climate change accelerate itself the further it escalates. And then finally, there is fossil fuel air pollution. Fossil fuels are portrayed as cheap, but when you take in the life cycle costs that they impose on society, they have absolutely massive aftershocks on human health by premature death, lost work hours to disease, elevated healthcare costs. There are huge savings to be had if we can move beyond fossil fuels and alleviate these costs. Looking at the overall cost effectiveness of fossil fuel reduction plans, to limit warming to about 2 degrees Celsius, what we would need is about an additional $500 billion per year over the next 30 years, added to a reallocation of about 95 trillion of already expected energy investment away from fossil fuels and towards clean technology. Now that would be a plan that would get us to about 2 degrees Celsius. Every $1 invested would bring around $3 to $7 in savings. And that seems like a lot of money to spend, but if you compare it, the size of these circles is relative to the amount of spending. If you compare it to the damage fossil fuels are doing through air pollution and the damage that we're expecting to happen from climate change, even if we only warm by 2 degrees Celsius, that orange circle will be significantly bigger the higher we are over 2 degrees Celsius. The investments that we need to address climate change no longer look that large. And in fact, they look like an intelligent allocation of money to save a lot of cost over the future. Now, this section will cover which technologies we need to deploy to meet climate change. And these technologies are already accelerating really quickly, but we need to get them moving even faster if we're going to meet this threat in time. So the speed of climate change is determined by total carbon dioxide in the atmosphere. So the amount of emissions we're putting out is just making that gap wider. Even if we cut those emissions to zero tomorrow, climate change will still be getting worse because this gap already exists. So to alleviate that gap, we need to first cut our emissions, then remove carbon dioxide. And there's also some additional options to buy more time that we're going to talk about later. Cutting emissions can be broken into energy efficiency, which is just investing in better technology that uses less energy to get the same level of output. The other two parts of cutting emissions are using clean electricity and clean fuels. So if we look at how energy is used, it's either used as electricity or through direct use, and most often that is fuels. That is something that is given to consumers as an energy product and then used in boilers or engines or other direct applications. So later slides are going to cover those. And here is just a summary of the core energy sources that are going to be the workhorses, either are the current workhorses or will be the workhorses of humanity's future. Renewable electricity is surging because its costs have been plunging because of a lot of incredible innovation happening over the last couple of decades. But even with that, even with renewables now being the cheapest source of new electricity around most of the world, they are not accelerating fast enough to fully take over global power grids for decades. Even in 2050, even in optimistic scenarios, we are still going to be relying partially on non-renewable electricity sources. And there are a lot of drivers here, but the core ones are storage and transmission challenges. Fundamentally, renewable power is intermittent, and we don't currently have cost-effective ways to store a lot of power over a long period of time to balance out that intermittency. In addition, renewable power tends to be best generated in remote sites, which are far away from where a lot of power is consumed. So building the long-distance transmission lines required to transfer that power is an ongoing challenge across the world. Now, there are technologies we can use to alleviate these challenges, but it's a work in progress. Then over to clean fuels. So example direct fossil fuel uses are gasoline used in vehicles, natural gas burned in boilers for indoor heating. Ways to decarbonize these. Option one are to convert them to run on electricity. So this is an option for some of these, and if that electricity is renewable, those activities become clean. Now, this is not an option right now for things like heavy industry, for instance, steel making or aviation, for many reasons. Electricity and renewables cannot effectively serve those entire markets just yet, though technology is improving towards that. One option that works across these is conversion to run on clean fuels. So we can use hydrogen, synthetic fuels, other options to be able to replace fossil fuels with clean versions. Now, I have an entire additional slide deck that dives into clean fuels on f4blog.org, so I definitely recommend checking that out. But the core takeaway is that those are also advancing really quickly. There's a lot of exciting progress, but we need to accelerate that development as well. Finally, there's carbon dioxide removal. So again, we don't just need to cut the net emissions of human civilization. We need to eliminate the gap that we've already put between the pre-industrial era and today's carbon dioxide in the atmosphere. So options to do that include planting new forests, include burning crops in sealed chambers and capturing their carbon, or include just capturing carbon directly from the atmosphere. Now, all of these options are promising. They could withdraw a lot of carbon, but they are going to come with a significant price tag. So the most efficient way for us to deal with this problem is to slash emissions as low as we possibly can, and then use these to balance out the emissions that we cannot abate, and then to bring our balance negative, and then to start pulling that carbon dioxide gap down to bring our climate back to a pre-industrial balance. All right, and finally, there is the emergency brake of geoengineering. I almost feel guilty even covering this in the lightning round because there are a few minutes of caveats that should be given before this is even discussed. The core of it is this is not a permanent solution. This is at best a last-ditch option to slow down the symptoms of climate change while we implement real solutions to deal with the core problem. No serious scientist who is working on this sees it as a good option. They see it as a worst case scenario that we should have in our back pocket just in case we need it. And I fully agree with that sentiment. Now, the inspiration for geoengineering is that major volcanic eruptions that shoot sulfur compounds high into the upper atmosphere actually cool the Earth for a little bit because those sulfur compounds reflect sunlight away from the planet. And we could artificially duplicate that using high-flying aircraft releasing reflective particles. So this would be a way to stall. It wouldn't reverse, but it could stall warming to buy us more time for building a global renewable economy that addresses the core challenge. The additional benefit here is that compared to large-scale investment to solve the actual problem, this Band-Aid for addressing the symptom would be relatively cheap and logistically relatively easy, which is part of why people are so understandably scared of it. You know, the real threat here is that people see it as an alternative to core climate action, and that is simply not true. This is only a way to slow down the symptoms of the problem, but fundamentally we don't have a future as a civilization if we don't address the problem itself. So again, this is a way that we could slow down the pace of warming in order to get more time for cutting emissions and for removing carbon dioxide. It is not a solution in itself. All right, finally, this is the conclusion of the slides. Fundamentally, we as the human race face a choice between continuing to depend on fossil fuels, which in the short term seem cheap, but in terms of their total impact and their long run costs are a massively expensive, unsustainably expensive way to fuel human civilization. They made sense at an earlier phase in our development as societies, and they simply don't make sense anymore. The alternative is freedom from fossil fuels through clean energy, investing in clean growth, yielding huge savings from avoided damages, and restoring a stable climate on Earth to secure humanity's future. And again, the technology roadmap we need to use to get there are cutting emissions through energy efficiency, clean electricity, clean fuels, removing carbon, and if absolutely necessary, using the emergency brake of geoengineering to buy more time for all of those earlier steps to play out. Now, on top of these slides, I also have appendix slides that dive into further questions, the way that energy is currently used in the US economy, renewables penetration globally, some looks at the emissions tracks that we are looking at and the cost of delay, some looks at how fossil fuels have fueled an incredible amount of prosperity in human civilization. You know, not saying they weren't necessary, just saying that we have now moved beyond the phase at which they can sort of secure a better future for us. And then a lot of sources. So the entire deck is full of footnotes that have a neurotic amount of additional commentary and detail here if you'd like to dig more. And I definitely recommend looking at these, looking at the full version of this briefing if you're interested, and looking at the other materials I have built, including a deep dive into clean fuels, cost modeling for green hydrogen, and other materials available at f4blog.org. In the meantime, thank you for listening. I'm glad you're on this journey with me.